Okay, so we are going to try this again, but this time we are going to simplify both sides and we're going to keep in theta. And we're going to do this because we are going to verify this expression for all angles, not just pi over 6, all of the angles. In order to do this, we have to remember our identities. The idea or the goal is going to be to get the left side looking just like the right side. Exactly what we did before, except now we're not having values. We're going to have expressions. So I want the left expression over here to look just like the right expression over here. Okay, here we go. I need to make secant of theta minus cosine of theta equal to or look the same as sine of theta times tangent of theta. So the best thing to do, guys, and what I suggest first is to rewrite everything in terms of sines and cosines. So that's what we're going to do. So I'm going to say this left side, changing it in terms of sines and cosines, I'm going to say secant of theta. I know its identity is 1 over cosine of theta. And minus cosine of theta. So I got the left side. The right side, in terms of its identity, I am going to say that it is just the sine of theta times the sine of theta over the cosine of theta, because that's the identity for tangent. All right, now I'm going to take a moment. I noticed the left and right do not look exactly alike, so I need to do another step. And I'm just thinking because there's two fractions here, there's 2 being multiplied over here, I'm going to go ahead and make one fraction on both sides. So there should be one fraction over here, and I'm going to make one over here. So I'm going to simplify the left and right and see what I have. Now to the left, we are subtracting, which means we need a common denominator. I have 1 over cosine of theta minus cosine of theta, and I know that cosine of theta is over a 1. So that means that my common denominator is going to be 1 times the cosine of theta, or just cosine of theta. And that means that I need to multiply this fraction here by the cosine of theta, both top and bottom. And that's going to give me one big expression. My denominator, cosine of theta. And in the numerator, I'll have 1 minus cosine of theta times cosine of theta is cosine squared theta. All right. Now, let's see what this is equal to. This is going to be equal to, well, we just have multiplication right here. And we know this sine of theta is over a 1, right? So we're going to have sine theta times sine theta. That's just sine squared theta. And then we'll have 1 times cosine of theta. Well, that's just cosine of theta. Okay. Looking to the left and right, they both don't look alike yet. But if I think back to the Pythagorean theorem, guys, the Pythagorean theorem, or the Pythagorean theorem, Pythagorean identity, the Pythagorean identity says that the sine squared of theta plus the cosine squared of theta is equal to 1. And remember what happened when I subtracted over the cosine to the other side? I ended up with sine squared of theta equaling 1 minus cosine squared of theta, right? And that again is the different forms we see are identities. So 1 minus cosine squared of theta, remember that's equal to the sine of theta. So I know this right here is just the sine squared of theta. So I'm going to substitute that in for the numerator. Denominator's cosine of theta. And notice these two do verify. I have the left looking like the right. I am verified. All right, guys, let's go to the next problem.